Hello, my name is Danny Beard, and this is my presentation on my photorealistic PS5 console and controller that I made for the VX4002 3D visual effects module here at Escape. This module's aim was to enable me to create 3D assets for use in the visual effects pipeline. Using Maya and Substance Painter, I had to learn industry standard techniques for modeling, texturing, lighting, and rendering a photorealistic object. For the deliverables, a minimum of one rendered image of the 3D model, fully textured and fully integrated in a backplate as either a JPEG or PNG. The resolution had to be in correspondence to the backplate resolution. A PowerPoint illustrating all aspects of the project, including at least 2 slides for each phase of the project ideas and references used during the process. For the modeling, all sides of the object and the wireframe, the UVs showing the final layout of the UV shells and the checker map, texturing showing the final look of the project in Substance Painter and the layer system, lighting showing the gray VFX ball setup, and a recorded presentation explaining the process. Before starting my desired object for this module, I further reinforced my Maya knowledge by learning the advantages of using different viewport settings. By splitting the view into 4 panels, it allows you to see different perspectives of your object in an orthographic view. This can be very helpful for lining up meshes with a reference blueprint. As a form of experimentation, I blocked out this vintage bellows camera using source reference images of its dimensions. To get the rough shape, I used polycubes and cylinders, then I cut multiple edge loops and beveled the edges so that the smooth mesh would have realistic corners. By switching between smooth and unsmooth mode allowed me to see which edges needed support. Having a smooth object is crucial for making the model look real. However, it greatly increases the size of the file. So using preview mode allows me to see the smooth version without sacrificing performance. For this module, I wanted to model something that I personally own so that I could examine the real thing meticulously and translate all the fine details into a 3D model. These are photos I took of my Spider-Man 2 PS5 console and controller to use as reference for my model. I arranged them both in a similar position as I wanted my final model so that I could have an accurate side-by-side comparison. Another way I ensured the resemblance of the console and controller was by sourcing detailed blueprints that I used as a guide in Maya. So that I could experiment with different tools in Maya, I began modeling components of the console using different methods. I made the panels by extruding a plane and using multiple bend deformers to get subtle curves on the plastic that contours around the CPU. The CPU itself was created by scaling a cube non-uniformly and beveling the edges so that it had a steep drop at the front. The side in which the disk drive protrudes proved to be a very complicated part of the modeling process. This is due to its sudden bulge halfway down the panel and the rectangular cutout for where you insert disks. When creating the vents, I used a sequence of modeled segments which I then curved using a bend deformer. After looking back at my reference images, I realized I had too many vents, and so I remade this component with the accurate number. After reviewing my original blockout, I realized I had multiple n-gons and tries that were ruining the topology of my model. For VFX, it is crucial to only use quads with the exception of a few tries where absolutely necessary. This is due to the fact that tries and n-gons cause shading errors, which could ruin the aesthetic of the final render. The main issue with my mesh had to do with the CPU, as adding the USB ports and power button gave me multiple edge loops that I needed to wrap around the object to avoid creating faces with more than 4 sides. In addition to this, I had to completely redo the side panel as the disk drive opening was causing creasing and shading errors upon smoothing the mesh. After fixing my topology and making everything uniform quads, I was able to smooth the model all at once and check it against my reference. I also modeled the stand and simplified versions of the internal components so that when the model was rendered there would be no empty space seen between the panels. To accompany the main console, I began modeling my DualSense controller by blocking out its rough shape using extruded cubes. So that I could achieve the ergonomic design of the controller, I moved vertices manually to allow the handles to taper down to a rounded point. Getting the main body of the controller correct was a tedious task due to its contours and smooth design. I had to constantly change the flow of my edge loops so that they would be evenly distributed along the surface of the mesh. Any parts that protruded from my controller I made a separate component to avoid altering my topology. These parts included the shape buttons, D-pad, joysticks, triggers, and the PlayStation logo that is used as a power button. To model the PlayStation logo, I had to sketch its silhouette using a CV curve, which I then extruded into a solid object. A con of doing this was that I was left with multiple giant n-gons, which I had to fix using the multi-cut tool. So that I had a crater for my joysticks to sit in, I used a circularize command on a grid of faces at the bottom of my mesh. Due to this section altering my even topology, I had to cut even more edge loops in the body so that when smoothed it wouldn't crease. After completing one side of the controller, mirroring it, and adding all of the separate components, I was able to refine any issues using the preview smooth mode. A particularly difficult process was trying to find a method to slightly raise the outer casing of the controller from the main body. In the end, I settled with using the multi-cut tool to draw the shell onto the surface and then extrude it from the body. As seen in these screenshots, my topology wasn't as clean as the console due to the complex shape of the controller. I believe that with further experimentation, I could make this controller much more accurate and have evenly spaced quads. So that I could render my console and controller together, I imported them into the same Maya scene. To add even more realism to the render, I used a sweep mesh to create a charging cable which had the appearance of being used. As seen in this screenshot, I clearly labeled all of my meshes and subcomponents in groups to identify their geos. Furthermore, I constantly switched between wireframe mode to ensure all my geometry was correct. To ensure I was prepared for Substance Painter, I duplicated all of the components into a new object, which I then fully smoothed so that it could be exported as an FBX file. UV unwrapping is a crucial but long process that you have to endure when texturing any 3D object. It is a way of cutting up the model so that all the faces can be laid flat. Working on flat faces allows the image texture to be applied evenly. To check for any incorrect UVs, I used the checker map to ensure that the tiles were uniform and not distorted. I used the planar mapping to project my mesh in one direction against the plane. This made it easier for me to select edges for cutting seams. When unfolding components, it can separate UV shells, which have to be fixed by sewing the edges together. The most time-consuming part of the editing process was the vents. Due to the fact that I manually lined up each vent, I had to individually unwrap all of one side. A strategy that saved time was copying the UV attributes onto the opposite vents and then reversing their normals to create all 40. Once I had all of my components unfolded, I took my largest pieces and set the maximum textile density that would fit the piece into a UDIM. Having several different materials and the fact that I wanted my model to look photorealistic, I organized my shells over 5 separate UDIMs. Each shell in a singular UDIM has to have the same textile density. My controller is positioned closer to the render camera, so I increased the size of my controller shells so that the texture would be a high quality. This is my complete UV map which expands over 5 UDIMs, correlating to a separate material. I organized the components into rough plastic, brushed metal, matte plastic, shiny plastic, and printed plastic. So that I could efficiently identify my separate UDIMs, I assigned different AI standard surfaces and renamed them in correspondence to their material. Afterwards, I exported my smooth mesh as an FBX and imported it into Substance Painter. To create the illusion of my unsmooth mesh being a much higher resolution, I baked my smooth version into the texture maps in Substance Painter. This means that when I wrap the textures around my lower resolution mesh, it will look the same as the smooth one, but won't affect the performance of Maya. Baking the textures also ensures that all of the data from the 3D model is transferred to the bitmap to avoid any missing textures. The defining characteristic of my PS5 is the Spider-Man themed prints located on the panels and on the controller. To achieve an accurate representation of this on my model, I designed custom PNGs in Photoshop. In Substance, I imported the PNGs as alphas so that I could project them as a stencil and apply paint exactly where I wanted. So that I could work on each panel individually, I created separate layers which I then masked to avoid any paint bleeding. To really sell the idea that this was a real object that had been used by humans, I spent an extensive amount of time applying small surface scratches and fingerprints. These textures were to be exported as 4K images, so I wanted to pack as much detail in as possible. Height is a way of giving a texture the illusion that it's protruding in or out from the main body of the mesh. This really helped me to promote that the grips were rubber and that the speaker holes went into the controller. As an additional aesthetic choice, I added emission to the light bars and the mute mic button so that it was closer to my reference. These are my final textured UVs from Substance Painter. And these are some Substance Painter renders I did using the iRay render engine. These are my custom clean plates and reference plates that I took using a DSLR camera. The backplates that were supplied in this module did not have the modern aesthetic or camera angle I desired for my final render. To go beyond the project brief, I decided to take my own photo. Once I had my backplate, I used a 360 camera to photograph the surrounding environment at different exposures. A critical part of the compositing a CG object onto a real setting is matching the lighting. A HDRI allows you to have an accurate representation of the environment where the backplate was taken. Having taken several 360 photos, they were formatted as DNGs and then merged in Photoshop to create a HDRI. On the day of shooting the backplate, I had taken multiple sets of 360 photos, which helped with selecting the most accurate lighting. Grey VFX balls are crucial in the production of films and still renders as they provide information about light direction, intensity, and shadows within the shooting area. Being able to use the Escape Studios industry standard VFX ball, it allowed me to produce a backplate and a reference plate so that I could perfectly recreate the lighting in Maya. To match the lighting, I had to import my HDRI into my Maya scene and project the image of my reference plate onto the camera. Following this, I created a simple polysphere with an AI standard surface material so that I could create a CG version of the grey ball next to the real one. The HDRI is a great starting point for the lighting, however, the highlights and shadows weren't as defined as they should be. To fix this, I added two Arnold area lights and positioned them below the lights in the HDRI. To create the shadow, I lined a plane up with the table in the backplate and applied an AI shadow map material to it. Through constant slight adjustments, I managed to accurately replicate the highlights and shadows on my CG ball. Succeeding the lighting setup, I positioned my PS5 model in front of the backplate and scaled it so that it was proportional to the monitor in the background. To have more variation in my renders, I put the controller leaning against the console from a different angle. Furthermore, I completely changed the position of my AI shadow mat and camera so that I could render using my other backplate. Another strategy I used to improve realism was by placing a soft area light and positioning it where the monitor is. This produced a dim blue reflection which could be seen on the side panel of the PS5. And here are my final Arnold renders for this module. Completing this 4-week module has allowed me to fully demonstrate my passion and skills for visual effects. I have always been captivated by the work that goes into creating photorealistic CG elements for use in the creative industry. I have been able to greatly expand my knowledge of Maya's software, understanding the importance of clean topology, using smooth mode, and how to efficiently lay out complex UVs. To improve, I would definitely take a different approach to modeling curved objects such as the controller. I believe I restricted myself by starting off with a cube-based mesh instead of a more rounded shape. This would have made my topology more even and reduced the amount of time I spent fixing n-gons. Overall, I am just as certain as when I started this module that working in the visual effects industry is a career path that I am keen to pursue. Thank you for listening.